Hello learners, grade 11. This video is going to be another video related to intermolecular forces, and this one was question 3 November 2018. It was a national paper, and obviously it's paper 2. Okay, so this question says the reaction below is used in the Haber process to manufacture ammonia. The boiling point of the substances in the reactions are as follows, and the reaction is between nitrogen and hydrogen will give you ammonia. Now the substances are H2, N2 and NH3, hydrogen, nitrogen and ammonia. And there is the boiling point of each substance. Now 3.1 says refer to the intermolecular forces and explain the difference in boiling point between NH3 and N2. Okay, so 3.1. Okay, so the first we are going to identify the type of intermolecular forces that they are in ammonia and in nitrogen. Okay, that was the question. What is the difference in boiling point between ammonia and nitrogen? So Lewis dot diagram for ammonia, you don't always have to do this one. Okay, it's nitrogen, it have a lone pair there, you have here hydrogen, and this one is a polar molecule. Polar molecule, the type of intermolecular forces, they will be hydrogen bond. Let's just fix this word, is hydrogen. Hydrogen bond is a type of intermolecular forces in ammonia. Okay, so now we're going to nitrogen. If you do the Lewis dot diagram, I'm not going to show you how it is done right now, but nitrogen can form triple bond. Okay, nitrogen can form triple bond. You can see here it is non-polar, polar molecule, and the type of intermolecular forces will be London forces. London forces. Okay, so that is the first step. You must always identify the type of intermolecular forces. Now, what you are going to do then, you are going to compare. For example, hydrogen bond is a stronger intermolecular forces than London forces. That is important. So this will relate to the energy. If hydrogen bond is a stronger intermolecular force than London forces, more energy is needed to break the hydrogen bond than the London forces. So more energy is required to overcome, more energy is needed to break the hydrogen bond, there. This is a mistake here, spelling mistake. Hydrogen bond than the London forces. You need more energy to break or to overcome the hydrogen bond than the London forces. Thus, the higher boiling point in ammonia than nitrogen. Okay, and that will be the final part. Okay, but you don't have to write that one because they're asking you to explain that part. Okay, but you can write thus the higher boiling point in ammonia than nitrogen. Okay, so let's go to the next question. Question 3.2. So question 3.2 say write down the formula of the substance in the table that will have the lowest melting point. Now the lowest melting point will also be the lowest boiling point. So this one is quite easy. We can see that the lowest boiling point is a hydrogen. So that is the answer for 3.2. They say the formula. So 3.2 formula is H2. Let's go to question 3.3. Now question 3.3, they said explain why the H2 will evaporate faster than N2. It's between H2 and N2. Refer to the type of relative strength of the intermolecular forces. So once more, we all have to do is to identify the type of intermolecular forces. For N2, we already did it, so we are not going to redo it. N2 has London forces. London forces. H2, now if we draw the Lewis dot diagram, H2 will be just one H, single bond with another H. The type of intermolecular force, this is also a nonpolar, will be also London forces. London forces. So both of them will have London forces. And that is going to be the first part of 3.3. Both of them have London forces. So if both of them have London forces, what is the difference between nitrogen and hydrogen? Nitrogen molecule is bigger than hydrogen. We have that the nitrogen, or N2, is a larger molecule, than H2, and therefore N2 will have a stronger intermolecular force. Remember, the larger the molecule, the stronger the London forces, the stronger the van der Waals forces, the stronger the intermolecular force. So N2 will have, therefore, a larger or stronger intermolecular forces. Therefore, N2 has stronger intermolecular forces. And then, obviously, that doesn't have to do with the evaporation, the rate of evaporation. Okay, so that is the question. It was done in a previous video about question 3 in November 2017. You can just go and watch the video, it will help. Let's go to question 3.4. 3.4, write down the formula of the surfactant in the table that will have the highest vapor pressure and explain. Last video we also spoke about vapor pressure. Let's start this question of 3.4 by defining vapor pressure. So let's start by defining vapor pressure. Vapor pressure is the pressure exerted by a vapor at equilibrium with its liquid in a closed system. That is the definition of vapor pressure. And what is the important thing you have to know? It is mentioned in the previous video. The stronger the intermolecular forces, the lower the vapor pressure. It is the opposite of boiling and melting point. Boiling and melting point, the stronger the intermolecular forces, the stronger or the higher the melting and boiling point. But vapor pressure is the other way around. The stronger the intermolecular forces, the lower the vapor pressure. So let's now answer this question. They say write down the formula of the surfactant in the table that will have the higher vapor pressure, that will be the one that have the lower boiling point, which is hydrogen for that question. So the formula is again hydrogen, and then we have to explain that one. Okay, so the answer is once more hydrogen for this question. Answer is hydrogen, and we have to explain why hydrogen have the lower vapor pressure. So what you have to say here, it has the weakest intermolecular forces. So it has the lower boiling point. And that's all you have to say in this question. Why it have the highest vapor pressure? Because it has the weakest intermolecular forces. Okay? You have the weakest intermolecular forces of all. You don't have to explain in detail. And it has the lowest boiling point. The lowest boiling point. So this is all for this video. I hope it helped. If it does help, please thumb up. Thank you for watching, and good luck.